in Blackboard, you have directions on how to make your own Tangram. So before you can participate in the lecture activity, you will have to have your Tangram created, and you might have it look something like this. This is done on cardstock paper so that it'll make it easy for me to work with as I try to make new shapes. You can buy very pretty tangrams already created, and for depending on what you are doing, you know, if you just want them to manipulate the shapes around, then that's fine to use those that are already made. But in this lesson, notice that when you're creating your Tangram by hand, that you are finding midpoints of a segment, and I think that you see that the square is formed inside. You're looking at perpendicular segments. I think there is value in creating it yourself. You have parallel lines, you have a parallelogram inside, and you have an isosceles triangle. All of those things can be talked about as you create the Tangram. Now, when you get your pieces cut out, we are going to be interested in finding the area of those pieces. So what you want to remember, when you created this, you found the midpoint of each side. So if your original square was 8 inches, that means that this is 4, and a triangle is base times height divided by 2, so you would have the area. Now, students typically do not have as much trouble finding the area as they do in finding the perimeter. So let me remind you of some things that we know about right triangles. So let's say that you have the right triangle with a base of 2 and a height of 2, and you're looking for this segment so that you can find the perimeter. The perimeter of a triangle is A plus B plus C. You simply add the sides together. So the perimeter of this is 2 plus 2 plus C, which is the hypotenuse. Now, we do not want to change this to a decimal. We want to find the exact value for the area. So to get this length, we use the Pythagorean theorem of 2 squared plus 2 squared is C squared. So 4 plus 4 is C squared. 8 is C squared. And now we want to simplify that by taking the square root. And so the square root of 8 is 2 times 4. The square root of 4 is 2, and this 2 remains inside. So the length of C is 2 radical 2. So when I'm looking for the perimeter, 2 plus 2 is 4 plus 2 radical 2. Then I put parentheses around that, and that would be in inches squared. So as you look at those pieces, you may need to put them back together to make the square so that you can see the relationship between all the pieces. So if you have a square that has a side 2 radical 2, then you know that the area of that would be 2 radical 2 times 2 radical 2. Well, 2 times 2 is 4, and radical 2 times radical 2 is radical 4. The square root of 4 is 2. 4 times 2 is 8 inches squared. The perimeter of that piece would be 4 times 2 radical 2, or 8 radical 2 inches. So that's the perimeter. This is the area. So for each piece, I would like for you to find the perimeter, and I would like for you to find the area. There is an important concept that you will be excuse me, getting. Let's say that your tangram is 4 inches by 4 inches originally. So the area of that tangram is 16 square inches. When you find the area of each piece of the tangram, it should be the same as the total area. So the area of each piece added together should equal the area of the original square. But what about the perimeter? If your tangram is 4 inches by 4 inches, then the perimeter is 4 times 4, or 16 inches. But once you find the perimeter of each piece, the perimeter of each piece added together is going to be greater than the original. And that's an interesting discovery for students. As the area remains the same, the perimeter gets greater. And so what we are doing here is modeling change. When we cut it apart, it does not affect the area, but when we cut it apart, it does affect the perimeter value. To develop spatial skills, we can have students looking at the tangram pieces and trying to model. How can you make Santa Claus with the tangram pieces? How can you make the bird and the rocket? So in doing these activities, you are creating spatial skills. So here's what you would do if you want to create Santa. You have the middle-sized triangle, the two small triangles, the large triangle, the squares here, and the parallelogram. Here are some other shapes that you can create. Working with tangrams is for all ages. When you begin looking at the perimeter and working with Pythagorean's theorem in order to get the length of the sides, you're dealing with middle school level, and we can also make this a K through 2 activity. You give the students the tangram pieces, and you give them a model already drawn out and have them fill it in. And this would be the tangram puppy. And this would be the tangram tree. One way that you can incorporate parents into your activity is to send home a letter saying that you are studying about tangrams, and send a tangram with them and ask them to work with their child to see if they can create some shapes together. And so you can give them several tangrams and they can cut them out and see if they can make some things other than the activities that we have already done in class. So this is a way of involving parents in the curriculum. And again, that's K through 2 activity with tangrams. I want to show you a book called Grandfather Tang's Story. And in this book by Anne Tompert, Little Sue and Grandfather Tang are lounging under a tree and just happen to have their tangrams with them. And little Sue would like for Grandfather Tang to tell her a story. And so he begins telling her a story about the fox and the dog. And as you progress through the story, the students are to create the items in the story. So you read the story, and then they pick out one of these to make. So the two foxes were very competitive. They get in all kinds of trouble trying to outdo each other. So one of them turns into a rabbit so he can hop away. So the students then are to use their tangram pieces to create the rabbit. And so the other one decides that he will change himself to a dog because the dog can chase the rabbit. And then the other one decides that he will outsmart, and because a dog can't climb the tree, he's going to change himself into a squirrel. And it continues on. What I want you to do with your tangram pieces is to make either Little Sue, Grandfather Tang, or the tree. So if you will make one of those and take a picture and upload that into Blackboard. Okay. If you need to go back and look at that longer, you can always go back in the video. The last thing that we are going to do is to use graph paper, and we're going to plot the tangram on graph paper. So when you finish, you should have a shape that looks like the tangram you made, except smaller. So you have ordered pairs that you are to plot, and then along the way you're going to be reviewing some geometric terms.